Okay, so this is a recording for the problem of the week. Actually, it should say number 9 there. Let me fix that real quick. Number 9. Okay, so this is being made available on the 29th. However, it's not really assigned until April 1st. Okay, so it's available as of March 29th. It's assigned for Monday, April 1st, which is a asynchronous day. It's due on Friday, April 5th, and it doesn't close until April 21st, 2019. All right, so part A, first of all, the directions say read the problem, write your answer for each part, make sure to show your work and explain when necessary, where necessary. Submit your completed assignment via the assignments tool in the course. So there's 4 parts, A through D, okay, and it's all working with the same data. We're building on it. Says Jonah works at a shop that prints t-shirts. The table shows how the cost of printing t-shirts depends on the number printed. So the first column is number of t-shirts. So 20, 30, 40, 50, 60, and then the total cost for printing those is 110, 135, 160, 185, 210. We're asking that part A, that you write an equation to show the relationship between N, which represents the number of t-shirts printed, and C, the total cost in dollars. So please make sure you use C and N when you write your equation, and your equation should go right here on this line. So just going back, right, this is your N, this is number of shirts, okay? The cost depends on the number of shirts. So that should help you with, your inputs and your outputs, okay? You can figure out the rate of change by looking at the change of the total cost, right? As it is relates to the change in the number of t-shirts. So for this one, it's kind of pulling back your knowledge for slope to be using the formula because there's no graph here, so you can't use the rise over run. But for slope, you can also do the change of y, which is y2 minus y1, the change of your y over change of x, x2 minus x1. So this is something that you learned with linear equations. We haven't really reviewed it yet this semester, but you can go ahead and check that out and look that up and see an example that you can use then to come back and do this one. So the change of our outputs over the change of our inputs, and that will give you slope. And remember the y-intercept, right? Y-intercept is when x equals 0. So what would be the value when x equals 0? Okay, so hopefully that helps to lead you in the right direction. All right, part B, graph your equation on this coordinate plane. Be sure to include an appropriate scale on each axis. I believe I updated this also. Make sure to label each axis. Make sure to label each axis with a description. So we have them labeled here for you, where N is really where the x-axis is and C is where the y-axis is. So you could actually go back and use that to help you with this if you were struggling trying to identify those. But I want descriptions. So what does N represent? When you have a graph like this, you want a description of what that is, and then a description here. The scale is referring to numbers. So you get to choose. You don't have to go every single square. You can go, 2 squares and then 2 squares and then 2 squares, or you can go every square. But what does that represent? What's the value? Is it a 1, a 2, 5, a 10? And so again, when you're doing that, you want to look at your inputs. They go up by 10. So you really don't, if you should hear 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you would never have enough space to plot anything for 60. So you can't do 1 unit, right? So you want to look at that and say, okay, what can I have each of my units be if my inputs are going up by 10? And then again, my Y's are in the hundreds. So maybe you don't want to start at, at 10, maybe we do 0, 50, and stuff like that. So the idea is that you have to pick your scale so that it could represent the values that you need to plot based on your table. Okay? So when you go to graph it, you can graph it using your equation, or you can graph it using these points. If you graph it using these points in part 2, that might actually help you go back and make sure that your equation was written correctly. So label the axes with descriptions, and maybe label the axes with numbers, the scale that you're using. Part C, what would be the total cost of an order of 120 t-shirts? Here I'm asking that you show your work. So you should use the equation and find the value of the total cost if you print 120 t-shirts. And make sure you put the equation of the answer with the description. So again, remember, unit of measure, right? Your answer is total cost, so it should be dollars, and it goes right there. Now, D is asking you to explain how you found your answer in part C. So one of the things you could do is just describe in words what you did in part C. So when you're showing your work, there's several steps. So when you're doing those steps, describe in words what you're doing that step and why. That's how you could do it. So I figured if you showed your work here, then you can refer to the work that you showed to actually put it into words. Okay, then save the document. Also, students have sometimes struggling with editing a Word document. You can use insert text box to label the sides, also to put numbers on here, and to plot the points, you insert shape, or you can copy this into Paint and use Paint to do it, and then copy the Paint picture back, or you can print it out and write on it. Okay, so there are your 3 options. All right. Yep, sorry. If you have any questions regarding this, please send me an email, come to office hours, or ask it before or after class. And I look forward to seeing your work.